Okay, quickly. The first thing we want to do is the difference between zeros and roots. What is the difference between them? Have you heard of root of an equation before?
Yes.
So what can you say about the difference? Is there a difference? Is it the same? Oh, the solution, the roots, the zero. Okay, some people kind of call it zero as well. They're kind of used interchangeably, but they have like a little difference. In the major difference is that zero is for expression. Zero is used for expression. Root is used for the equation. So for example, if you have equation x, quadratic equation x minus 1, x minus 2 is equal to 0, you get two answers, right?
Yeah.
These are the solutions, right? Yeah. These solutions are called the roots of the equation.
Yes. Yes.
Okay? But this is an expression. F of x is equal to this is an expression, isn't it?
Yeah.
The values of x that can make this 0, what are they?
All the zero.
Oh, those are called the zeros.
Those are the zeros. The values of x you will put in here. Remember, this is x squared minus 3x plus 2, right?
Yeah.
There are two values you can substitute into this function, and you will get 0 as your result. Those two values are called the zeros of this expression. Okay? But when you solve this f of x is equal to 0, which is the first one, you get two results, the solutions of the equation.
Yeah.
Those are the roots of the equation. Yanko, are you confused?
I'm still kind of confused.
Okay. You know the difference between expression and equation?
Yeah.
Okay. This x squared minus 3x plus 2 is an expression.
Okay.
Let's call it f of x. Okay?
Okay.
This f of x is equal to 0 is an equation,
Yes.
which means x squared minus 3x plus 2 is equal to 0 is an equation, right? When you can solve this, but you cannot solve this. You can only evaluate this.
Yeah.
When x is 2, when x is 1, when x is 14. So you can put so many, infinitely many values of x. The domain is the entire R. Okay?
Yeah.
You can put infinitely many values of x, but only two of them will make it 0.
Okay, yeah.
Because if you plot the graph, these two that will make it 0 signifies the point where it crosses the x-axis. So that will be 1 and 2. Okay? Because f of 1 is equal to 0 and f of 2 is equal to 0. Since these two values can be substituted into this expression to make it 0, they are called the zeros of the quadratic expression.
Okay.
Okay? So the word 0 is used in expression. Okay? The equivalence of that when dealing with equation are the roots. If you solve this equation, you will get x is equal to 1 and x is equal to 2. What that means is that for this mathematical statement to be valid, x must be 1 or x must be 2. So we call x1 and x2 are the solutions, right? Or the roots of the equation. So the word root is used when talking about equation.
Okay. Okay.
Do you understand?
Yeah.
So again, if x is equal to 1 is a 0 of f of x, then x is equal to 1 is the solution of f of x is equal to 0. Does that make sense?
Yeah.
If x is equal to 1, because you put x equal to 1 here to make it 0, right? So, oh, x is equal to 1 is actually a 0. What that means is that x is equal to 1 can make this function 0. Okay? The implication of that is that x is equal to 1 is a root when f of x is equal to 0 itself. It's an if and only if statement.
Yeah.
Do you understand that? So that is the difference between these two. So what we intend to do today is to distinguish between the two. I'll write a short note for you. The next thing is to be able to factorize polynomial. We have done factors theorem. We will use our knowledge of factors theorem to factorize polynomial. okay, then we'll be able to find zeros of polynomial or the root of polynomial equations, depending on what is given. Does that make sense? And that's all I want us to be able to achieve by the end of this lesson. By tomorrow, we'll do fundamental theorem of algebra, which is just what I've just explained here. That is, any polynomial of degree n has n roots. So if there are power 3, we should expect 3 answers, and how to go about it is what we are going to try to do by tomorrow. All right, so I will call the first part zeros and roots. Thank you, sir. Okay, let's P of x be a real polynomial. What do I mean by a real polynomial?
No, not the man.
What do you mean not complex?
No, no.
Involve where?
In the roots of the answer.
No, the answers may be. It may be a real polynomial with complex roots. We're going to see that.
Oh, right. Okay. There's no I in
The coefficients.
coefficients.
The coefficients are all real numbers. That's what it means. Thank you. So let's P of x be a real polynomial. Okay? The values, that's right. The values xi for which P of x is equal to 0 are the zeros of P of x. P of x is an expression here, not an equation. But the values xi for which Pxi like this is equal to 0. All those xi you can substitute and come out and generate 0 are the zeros of the polynomial. The term 0 is used. Okay, maybe I can put that as a summary later, like a notes, like a remark later. Sorry about that. Okay. The roots of a polynomial equation. See, I use the word equation here. P of x here. Polynomial equation P of x is equal to 0 are the values xi which satisfies the equation. Which satisfies the equation. What's the equation? Px is equal to 0. See, that comes, in fact, it may not be equal to 0. It may be Px is equal to something. Understand what I mean? Now, a note, or some notes or remark. 1. The term 0 is used for expressions, while roots the term 0 is used for expression, while roots is used for equations. That's the main difference between them. 2. Xi is a 0 of P of x. If and only if what? Anyone want to try to complete that? Xi is a 0 of P of x if and only if.
It's not complex.
It's a
Polynomial.
Don't say it. Which of these do you mean by it?
X is a root.
if there's no x, I said xi.
xi.
If and only if xi is a root of p of x is equal to 0. Understand that, Yanko?
Yeah.
The quadratic that I gave you earlier, 1 and 2 are the zeros of that factorization. If and only if the same 1 and 2 will be the result when you equate it to 0, isn't it?
Yes.
It's a biconditional statement. Okay? So that's that about that. So the next thing is how to factorize our polynomials. Factorization of polynomials. Or maybe we can combine it with zeros. Factorization and zeros of polynomials. Just say p of x. So the main steps to factorize p of x. Step 1, use trial and error to find a factor. I'll tell you what I mean by trial and error. To find a factor using factors theorem. Or should I say, I use twice? No, I don't want to do that. Okay? By factors theorem. Factors theorem. So once you do that, divide p of x by the factor. Then factorize the quotients. These are the three steps. Of course, these 3 steps can be very long, which is okay. We are up to the task. So I will combine these 2 together. Factorize the following polynomials maybe not a general statement. Miss Joey, I come to class. Just ignore me and do your thing. You see, Carolina knows what to do. She just ignores me. Like it doesn't exist. Get him out of my head. Factorize the following and hence find the zeros of the polynomial, of course. So the first question. Let's look at this. Let's call this f of x is equal to 4x cubed. Please bring out your calculator. Minus 11x minus 6. Next question. Please, I want everybody to pay attention. Elson, and make sure we can see this up to here. Yeah. Nice. Thank you. Now, listen, everyone. To factorize, all you need is to find a factor. This is the idea. Please listen, like I said. You want to factorize 30. Okay? You want to factorize 30. Of course, by not using the trivial factors. What are the trivial factors?
1
1 and 30. Trivial, like obviously. Like it's obvious, 1 can divide it, 30 can divide it. So they are trivial factors. So again, if you use trial and error, oh, can 2 divide 30? Yes. So at first we say, oh, 2 can divide 30. We get that. How do you get this 15? You divide. That's what the second step is telling you. You divide. Once you get 15, then you try to focus on 15 now and break 15 also into pieces. In this case, the pieces will be 3 and 5. So once we're able to do that, you now say, oh, it is now factorized into 2, 3, and 5, like that. Then you have 3 linear factors. This is the idea I want to use. But how do you get the first one? Is by trial and error. What do I mean by trial and error? You substitute 1, minus 1, 2, minus 2. Because whatever you substitute, remember your factors theorem. If f of a gives you 0, then what is the factor of f of x? Factors theorem from last week.
X minus A.
X minus a. Oh, come on, guys. If f of x is divided by x minus a, the remainder is f of a. Because now, if f of a is now the remainder, which is 0, it means this is not just a divisor. It is what? A factor. Do you understand what I'm saying? So we are using the factors theorem here. Yanko, understand?
Yeah.
So you substitute different values. So I want you to try 1 minus 1, 2 minus 2, 3 minus 3. You should be able to get one that will give us 0, so that we can get the first factor. That's why I said use trial and error to find a factor. Everybody, quickly, check. Substitute 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4. I'm sure you will get something. I said substitute, not write, dude. Use your calculator, quickly. Don't waste time. That's why I asked you to bring out your calculator. 1 minus 1, 2 minus 2, 3 minus 3. One of them will give you 0. Then we can say by factors theorem. So tell me once you find one of them. You just open the format in your calculator with brackets so that you can just change the number. You don't have to type everything all over again. Be smart with it. Negative 2. Everybody confirm that. I don't trust Alex in the morning.
What about the afternoon?
Okay, yeah, in the afternoon. So, since f of minus 2 is equal to 0, then what is the factor?
X minus 2. X plus 2.
Come on, talk. Then what is the factor of f of x? I just explained something now.
X plus 2.
So you shush henceforth. I need to know that everybody's following. Then x plus 2 is a factor of f of x. Any question? This is by factors theorem. You may even have that. By factors theorem. Understand? Okay, like go on, or you understand?
I understand.
Alex? You? So? Understand? Great. Now that we have found one factor, the rest is to divide. So, divide. Your polynomial is 4x cubed. Remember all the rules for division. You should leave space if a particular term is not included. 4x squared minus 11x minus 6. So you have discovered x plus 2 as a factor. So we divide. The first one will be, quickly,
4x cubed.
4x
Squared.
So this will be 4x cubed, plus
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 8x squared.
8x squared. Then we subtract. Yes?
Negative 4x squared.
So you get negative 4x squared, then negative 11x. You go again.
Negative
Negative
4x.
4x.
Negative 4x,
So negative 4x squared minus
minus
8x.
8x.
Subtract again. 0 and
Negative
9.
3x.
3. You get 9. Then this, next,
3.
negative 3,
Negative 3x minus 6.
and everything is
0.
So this is a confirmation that it is indeed a factor. If you get to this point and there's a remainder, go check yourself. Is either you have used the wrong factor or something is wrong with your division, and it will affect your quotient. So currently, please focus. Currently, so hence, our f of x is now what? It can be written as product of two factors now. What are they?
Oh, x plus 2.
X plus 2 and
4x squared minus 4x minus 3.
good. This is quadratic. You factorize using your knowledge of quadratic. Understand? So this will be x plus 2.
2.
This is 4x squared. Factors of 12, that gives 4. You know how I got my 12?
2 and 6.
You know how I got my 12, right? 2 and 6. So it's going to be minus 2, no, plus 2, minus 6, yes? Talk to me, please.
Yes.
So that, you see, I'm carrying everything along. Or you may say, oh, my quotient, you factorize your quotient, then you write f of x. If you're writing f of x, everything has to be included, not just the quadratic.
Okay.
So, again, I put this in a bigger bracket because there will be smaller brackets. 2x plus 1, minus 3, 2x plus 1. Everybody knows this, so I'm not wasting time to explain. Yeah? So that finally, we have x plus 2, 2x plus 1, 2x minus 3. We have just factorized the polynomial. The second question says, find the zeros. What does it mean to find the zeros?
That means whatever value you substitute into x, it equals to 0.
To make it 0. All you have to do, to find the 0 of the polynomial, what do? You equate that thing to 0. That, oh, I'm looking for the values of x that will make everything 0. Understand that?
So make it an equation, find the
You just
values.
make it an equation,
Okay.
and you find the values of x. Understand that? Okay, so the zeros, so to find the zeros of f of x, of course you don't have to write all this, it's just for you to know what I'm doing. Find the zero. I don't want to look back and see that you guys are just messing around at the back. Please, I love my mood. Don't change it. If you're not ready to learn, get out of my class. Because I'm going to ask questions now, someone is going to look confused. There's any little time you want to play. Get out of here if you want to play. To find the zeros of f of x, put f of x itself is equal to 0. That's what it means. What are the values of x that will make this entire function 0? Which means when x plus 2,
And then 2x plus 1.
2x plus 1,
2x minus 3.
2x minus 3 is equal to 0. So clearly, x is equal to negative 2,
Half.
x is equal to negative half, and
positive 3 over 2.
x is equal to 3 over 2. So these are the zeros of the polynomial. Okay?
Mr. Daniel, we don't need to do the x
Put
plus
equal to
2
0,
equals 0.
you're in IB class.
Okay.
Just move on. You're welcome to show me that, but there's no need. The reason we make it compulsory at those lower level, because if everybody starts skipping the steps, they won't understand what is really happening. But now you've gone through those rigorous stages, you can write this directly. Does this make sense, please?
Yep.
Okay, so I'll write the next question, but you will do it. So you may leave space for this so we don't waste time, so that you can go straight to the next one. Use me. Bx is equal to x cubed minus 3x squared minus 10x plus 24.
Please look at the space to be left and just focus on number B. G of x is 3x cubed minus 2x squared minus 37x minus 12. The same instruction. Just write one in the class. I'll stop you in about 5 minutes. Hopefully you have done one of them.
We don't need to write by factors theorem, right?
No, you don't.
Okay.
Have a question?
No, I just did my math wrong.
Yes, sir.
I have a question.
Ask, and it shall be explained.
I'm not allowed to do this. It's like for this one, I just put the
That's fine. Yeah.
This is fine, right?
Yeah. That's a money quadratic, so I don't expect this.
So
If you have one here, just write the factor straight away.
okay, but what if it's not one? Do I have to
If
do
it's
it
not
like that,
one,
or can I also do it?
You can also do that if you understand the scissors method.
Okay then, yeah.
That's fine.
How do you turn this thing? It's not you can't see the third side.
Just start.
With force? Just
Not with force. It's not that. Oh, this is too tight. Is it this one or this one?
I think
One of
it's
them
one.
is too tight. I'll have this one.
Okay.
Thank you, sir.
Did you? Well, what's the problem?
Also, negative 10.
Minus negative 15.
Minus, which is positive.